If 180 grams of potassium hydroxide are dissolved in enough water to make 750 milliliters of solution, what is the molarity of the solution? So, as I told you many times, in molarity, we're going to be using a lot the molar masses. So, knowing how to get a molar mass is important. Before I go into this topic, I'm better gonna show you as a review, okay? Calculation of the molar mass as a review. But the one of the hydrates, okay? I know the hydrates are not common, but still, you need to know it, okay? So, imagine that you have this compound. And I say, okay guys, okay man, okay. Okay guys, you need to get a molar mass of this hydrate. First of all, as a reminder, how to name it, okay? First of all, you will need to name the ionic part of the hydrate, which in this case is going to be nickel 3 sulfate, okay? That's going to be the name. Nickel 3 sulfate. And then the part of the hydrate, okay? For the number 6, the name the prefix used for 6 is hexa. Okay? And then instead of water, you're going to write hydrate. That's how to name it, okay? But you know, this is not the main topic, just for you to remember. Now, the important thing, what comes, okay? I told you there are no common hydrates in the quiz, so don't worry, okay? Don't worry. Trust me. I know you never do, but trust me. First, we calculate the number of atoms of each element. So, I have nickel, and for nickel, it's pretty easy. I have only 2. For sulfur, I have invisible 1 internally and 3 outside the parentheses. So, inside the parentheses, I have invisible 1, and outside the parentheses, I have 3. In total, I have 3 sulfurs. In oxygen, I have 4 oxygens inside the parentheses, 3 outside the parentheses. So, I have 4 times 3, which is 12. I continue now with the water part, and for this, I apply distributive property. 6 is my coefficient, so for my hydrogen, it's going to be, the coefficient 6 times my substrate 2. In total, I have 12 hydrogens. And for oxygen, it's going to be my coefficient 6 times the invisible 1. So my coefficient 6 times the invisible 1, 6. And I multiply times the atomic masses of each. Okay? Okay. I don't remember the one of nickel, but for sulfur is 32.064. For oxygen is 16 rounded because I'm lazy. For hydrogen is 1. For oxygen again is 16. And let me search for nickel.
58.70.
58.70. Okay. Wait. I do this in the calculator in a whole step. Okay. Guys, to calculate the molar masses, you can use your calculator and do it in a single step. You don't need to take so long to calculate the molar mass. Okay. So let me share again. So 2 times 58.70 plus 3 times 32.064 plus 12 times 16 plus 12 times 1, which is 12, plus 6 times 16. Do you get the same as me? As you can see, I don't use parentheses. All I do is I multiply and I add. I separate every element just with the plus symbol. Do you get the same answer as me? 500,
Yes.
513.592, okay, grams of all that compound. So my point is that you don't need to spend so much time in calculating the molar mass. Okay, now let's see one example here. I don't know if you have a doubt in the first, Xavier.
Miss, can you explain the number 5 from the glassware?
The number 5. Okay, the 5. Okay, wait.